Okay, gentlemen, 5.4 day 1 takes a look at factoring when we have ax squared plus bx plus c, but the a value here is 1. So technically, it's really x squared plus bx plus c. That's the standard form of a quadratic. We're going to look quickly at expanding and simplifying, which again is a review, of course, from last day. Expanding as the opposite of factoring. So x plus 5 squared you recognize as looking like vertex form, but really that's x plus 5 times x plus 5. And we learned that this is really a perfect square trinomial because we're multiplying the same thing by itself. So x times the x gets me x squared. X times the positive 5 gets me 5x. And 5 times x is another 5x. So altogether that's 10x. And the last two terms, 5 times 5, is 25. And again, we talked about the shortcut being square this first term, x squared, and the last term will be 5 squared. So you'll notice here the first term is x squared, the last term is 25, and a shortcut to getting the middle term would simply be to multiply x times positive 5 and then double it. The reason why we double it as a shortcut is because, as I mentioned earlier, you have x times 5, and then the very next step you have 5 times x. So that's technically double, and that's how we get our 10x. The next example for number 1b here is you need to recognize this as a difference of squares. We have the exact same binomial, 4x and 5y, except we have one being subtraction and one being added. Recognizing that as a difference of squares, and from completing your homework, you should recognize that this ends up being 4x times 4x, which is 16x squared. The middle term will disappear because we have 4x times positive 5y, and then we have a negative 5y times 4x, and that will eliminate each other. The final step here would be the negative 5y times positive 5y, and that will give you, let me just change that to negative 25y squared. You should try this one again on your own. If that didn't make sense or you're confused, you're not 100% sure, try that one again on your own on a separate sheet of paper and expand this, and you'll see 4x times 4x is 16x squared. 4x times positive 5y would be 20xy. And then negative 5y times 4x will get you a negative 20xy. And that's what these two eliminate each other. Okay, factor completely. Remember, the first step in factoring is always to look for a greatest common factor. In this case, the greatest common factor between these two terms is the number 3. So I'm going to take a 3 out, or factor out a 3. 3 times what will represent 3x? 3 times x. And for the second term, 3 times what will represent positive 12? 3 times a positive 4. So if I were to expand this, 3 times x is 3x, and 3 times positive 4 would be positive 12. And I've accurately represented my binomial. Here, we should recognize this as a difference of squares again. 4x squared subtract 25y squared. And so that is, the easiest way to do this is to, let me just erase this circle. The easiest way to do this is to square root the first term, square root the second term. So if I square root 4x squared, the square root of 4 is 2, and the square root of x squared is x. The square root of 25 is 5, and the square root of y squared is y. Now, to get a difference of squares, as I just mentioned above, we eliminate the middle term, and the only way that's going to happen is if there's subtraction here and addition here, and it's the exact same binomial, just one is being added, one is being subtracted. That's how we end up with two terms and a middle term is gone. Okay, in order to factor, we need to know our multiplication tables. So in this case, find two integers with a product. Again, that's the answer to multiplication. So they two numbers that multiply to 12 and add up to 7. A positive 4 and a positive 3 will multiply to 12, and they also add up to 7. two integers with a product of negative 12 and add up to negative 1. In this case, our numbers are still 4 and 3. If I need to multiply to get negative 12, then either the 4 has to be negative or the 3 has to be negative, and the other one has to be positive. So one has to be negative, one has to be positive for me to have a product of negative 12. Because as you know, negative times positive is negative. But their sum must equal negative 1. So the giveaway here is the fact that their sum has to be negative 1 means that the larger number, in this case the 4 will become the negative and the 3 will be positive. Now, on a number line, technically the 3 is a larger number, it's greater. However, when we're adding up negative 4 plus 3, I'll end up with a negative 1. And so in that case, I meant just looking at the number without a positive or negative sign. The numbers themselves, 4 and 3, 4 being the larger. He gets the negative, so that when I add them, I end up with a sum total of negative 1. In this case, I want a negative 12 again when I multiply, but I want a positive 1. So I'll make the 4 positive and the 3 negative. So when they add together, I'll end up with a positive 1, but they'll still multiply to get me a negative 12. If I want a positive product, but a negative sum total, then both numbers are going to have to be negative. When they add together, I get negative 7, and when they multiply, the negative is gone, it becomes positive. That knowledge comes in handy here for factoring. So when we're factoring, when a is equal to 1, again, there's an imaginary 1 there. When we're factoring with a equal 1, we look at the third term. We call that letter c, ax squared plus bx plus c. So when the c value is 12, I'm looking for two numbers that multiply to positive 12 and will have a sum total of positive 7. Well, if we look above, we know that to have a product of 12 and a sum of positive 7, my two numbers are 4 and 3. So a quick way of factoring this, we know that x times x is going to be x squared, and that's great. We've got our a value taken care of, or our first term taken care of in our trinomial. And to get the second two, we're going to use what we just learned, our positive 4. Oops, let's get that done properly. Positive 4 and positive 3. And if you FOIL, you will find that you'll end up with x squared plus 7x plus 12. And it's that simple. Let's try it again. Let's look at this here. We're looking at the negative 12. I want a product of negative 12 and a sum total of negative 1. So we want two numbers that multiply to get the c value and add up to get the b value. Two numbers with a product of negative 12. That's exactly like number 4 here. Our two numbers are negative 4 and positive 3. So x minus 4, x plus 3. Let's try this again. Negative 12, a product of negative 12 and a sum of positive 1. You look at number 5 and you'll notice that our two numbers are 4 and negative 3. So x, again, x times x will get me my x squared. And in the next calculation, I need to have a positive 4 and a negative 3. The positive 4 times the negative 3 will end up being negative 12, and the middle term will be a positive 1, because when I multiply x times negative 3, I will get negative 3x. And when I multiply 4 times the x, I'll get positive 4x. And of course, negative 3x plus 4x will end up being positive 1x. Here we're looking for a product of 12 and a sum of negative 7. Again, we start off like this, and we end up with negative 4 and a negative 3 like you see in number 6, because negative 4 times negative 3 will be my final term in my trinomial, and that's positive 12. Negative times negative is positive. And when we're distributing x times x is x squared, that's my first term. X times a negative 3 gets you negative 3x, and negative 4 times x is negative 4x. Those two are like terms. Negative 4x and negative 3x add up to negative 7x, and that gets me my middle term, and it accurately has been factored and accurately represents my trinomial or my quadratic. In this case here, we're going to factor by first removing the GCF. As I said earlier, the very first thing you want to do is remove the GCF. In this case, the a value is not 1. So we're going to look at we're looking at the numerical coefficient here, the 3, the 12, and the 9, and I can take a 3 out of each of those terms. So if I take a 3 out, 3 times x squared will be 3x squared. 3 times positive 4x, don't forget the x. It's a common mistake at this stage. that many students forget to put the x there. So 3 times a positive 4x will accurately represent the positive 12x, because 3 times 4x is 12x. And then 3 times positive 3 will get me my positive 9. So I've now taken out the GCF. It's going to erase those. Now taking out the GCF, and now I can factor. So the next step would be like this again. Which two numbers multiply to positive 3 and add up to positive 4? Really what you're doing is a factor tree, looking at the factors of 3. 1 and 3, it's a prime number. So how can I get a product of 3? Well, 1 times 3 is 3. So I know that's going to be it's going to 1, and that'll be a 3. However, how do they add up to 4? Well, then I need a positive 1 and a positive 3. Let's try that again over here. I can remove the greatest common factor here, which is 2. 2 times x squared is 2x squared, minus 11x, and then plus 28. Okay, so now I can look at this and this, and I'm looking for two numbers that multiply to 28 and add up to negative 11. If you know your multiplication tables, you know 7 times 4 is 28. And in this case, I need to have a sum of negative 11. Well, two numbers that add up to be negative, but also multiply to be positive, means they both have to be negative, because negative times negative is positive. So here we have negative 7 and negative 4. And you may be thinking, do I need to put the 4 first or the 7 first? It doesn't matter what order you do that in. And that's it. If I were you to go back, it'd be great to master the skill of factoring when A is 1 and removing the GCF. It's great to go over these questions again and practice them on your own and come back and see if you've got the same answers. All right? Good luck.